everyone, welcome to today's methodology breakdown. Today we're going to be talking about the Greenhouse Gas Protocol Guardian policy and how that could be used to coordinate GHG data across supply chains and improve Scope 3 and product accounting. So a little bit about our agenda today. We're going to talk about Envision blockchain, give an overview of the Guardian. We're going to talk about the GHGP Guardian policy in general, why Scope 3 is important, challenges with Scope 3 accounting. We'll talk about the demo use case, quick review of the workflow and schema, and then we'll go into a pre-recorded demo. A little bit about Envision blockchain solutions. We build applications for Web3 space, and we focus on guiding organizations through three major milestones on their Web3 journey: the use case analysis, proof of concept development, and scaled deployments. A little bit about the Guardian. Since 2020, open source Guardian, maintained by Envision Blockchain with support from the HBAR Foundation and Swirlds Labs, has utilized the Hedera public network to enable transparent, auditable, and traceable documentation of GHG emissions and environmental tokens. In 2021, Envision Blockchain introduced the Managed Guardian Service, an SaaS solution tailored for GHG emissions and carbon markets to simplify environmental application development, offer core Guardian features like the policy workflow engine on a scalable platform. MGS, launched in 2022, supports organizations in creating traceable environmental tokens on Hedera's ledger, advancing the measurement and accounting of GHG emissions and reductions. So basically, by using the Guardian, we can digitize, streamline and simplify complex GHG accounting. We can leverage the DLT to share reliable GHG metrics across supply chains and build trust and accuracy into GHG accounting. So a little bit about the GHG Protocol Guardian policy. The GHG Protocol is the leading standard for organizational and product greenhouse gas accounting. More than 9 out of 10 Fortune 500 companies that report to the CDP use the Greenhouse Gas Protocol. The GHGP Guardian policy utilizes digital workflows and schemas to allow users to create organizational profiles, assets and facilities, vehicles, equipment, add GHG sources to the assets and add data to the sources, auto-calculate emissions, generate and verify reporting KPIs. And some key features of this policy is the ability to take some of those GHG sources and attribute those emissions to products and services, calculate and publish product carbon footprints. And this is in accordance with the Pathfinder Framework, which is an initiative to help standardize and increase the sharing of greenhouse gas data across supply chains. And those PCFs can be referenced to support Scope 3.4 calculations to improve Scope 3 calculations. So understanding why Scope 3 accounting is important. Scope 3 is currently optional under the Greenhouse Gas Protocol, but it's actually becoming the next frontier of greenhouse gas accounting. It used to be mainly larger international and publicly traded companies were focusing mostly on Scope 1 and 2 emissions. Now they're beginning to more often set targets for Scope 3, which involves their emissions from their supply chain, transportation, and products, things like that. And as they are setting targets, they're starting to look towards their suppliers and their supply chains, which might be made up with more small to medium-sized enterprises, and asking them, are they measuring their greenhouse gas emissions? Are they taking measures to reduce them? Because ultimately, these companies are looking to reduce their Scope 3 emissions. Also, regulations and standards are starting to place a focus on Scope 3 emissions. The California Climate Corporate Data Accountability Act has Scope 3 emissions reporting by 2027. The Science-Based Target Initiative, also known as SBTI. All companies that submit a target to the SBTI for validation complete Scope 3 inventory, and 96% of them have targets that involve Scope 3 emissions. Scope 3 targets are also a requirement under the SBTI net zero standard. Another reason why Scope 3 emissions and product emissions are important is because it can represent a potential for market differentiation. If you're a supplier or you're producing products that have a low carbon footprint, that can help upstream suppliers and supply chain partners reduce their Scope 3 emissions downstream as well. So as companies are looking to meet their Scope 3 targets, they're gonna need low carbon suppliers and products to meet their commitments. And this represents an opportunity for companies in that supply chain to gain a competitive advantage. And in a digital GHG data environment, low carbon products and suppliers will be easier to discover and benchmark, and you'll also be able to identify demand for low carbon products and carbon offsets by assessing data that's available on companies' GHG emissions and what targets they have, and whether that involves Scope 3. So, some of the challenges with Scope 3 GHG emissions. So, one of the prevailing methods of calculating Scope 3 emissions involves environmentally extended input output factors, also known as EEIO factors. These come with a high margin of error. They generally involve emissions factors that are averaged over large geographic areas. They might be averaged over many different product types, different manufacturing products, transportation distances, and outdated data. So all of this results in basically a very high margin of error, low dependability, and it's just not the most accurate way to track GHG emissions. So, for example, if you're looking at paper and there's a certain amount of emissions associated with a ream of paper, you might find an EEIO factor that could be old. Maybe it's from 2018. It could be a geography of all of EU. It might just be only applicable to basic white paper, and it might not reflect the actual context of the people who are actually using the paper. They might be using a different kind of paper. Their suppliers might be using efficient processes. They might be using offsets and RECs. Their suppliers might be local. None of that's going to be represented in an EEIO factor that's old and spans a large geographic area. Slightly better approach would be using a supplier-specific PCF, but these are rarely available. They're difficult to quantify and update, and they can be generally static. So some of these PCFs that people use today, they could be remain static for periods of up to 5 years. And in that meantime, supply chains and operations remain dynamic. Their actual emissions, their actual operations, that's going to change, and those changes aren't going to be reflected in their PCFs in a very timely manner. Other challenges are low levels of assurance and verification rates. The vast majority of GHG inventories, especially Scope 3, are not verified. There's a lack of expertise and qualification requirements for people conducting greenhouse gas inventories. Digitizing methodologies can help streamline and simplify that. And there's generally a lack of data coordination where there's a lot of overlap between these emissions. So someone's Scope 3 and Scope 2 emissions, that's someone else's Scope 1 emissions. Also, lots of overlap in the data behind product emissions and Scope 3 emissions. And companies aren't really sharing that data very well with each other. And if they did, that would improve accuracy a whole lot. So these are the GHGP data quality indicators. Just want to go over this real quickly. And as you can see, if you're using something like an EIO factor, it's going to be poor data quality based on pretty much all of these indicators. The technological representativeness, it's very unlikely that it's going to represent the actual equipment and technologies used by the actual suppliers. Temporal representativeness, they remain static for a long time. Some of the data is really old that people are using. It's averaged over large geographical areas. Basically, every one of these it shows that the data quality indicator is valued by GHGP. Those approaches are not very high quality data. So why digitize methodologies? I think we got a little bit into that already, but it improves standardization. You can automate calculations so that users could just focus on the inputs and they don't need to be bothered with the calculations that a computer can do for them. Also DLT and data coordination between multiple users. So all of these things can enhance transparency and trust, improve data quality, and having emissions tokenized and KPIs available on chain facilitates better coordination across supply chains. So data can be entered into Guardian policy either manually or automatically through APIs to help seamless integration, increase data traceability, and allow for custom solutions. So I just want to get a little bit into the demo use case right now. We're going to talk about two different companies utilizing the GHGP policy. Company A is a trucking company. They're going to digitize their greenhouse gas inventory and attribute certain emissions to their service and publish a PCF for their transportation services. Company B is a water bottle manufacturing that uses Company A for their upstream transportation. They reference their PCF to calculate Scope 3 emissions from upstream transportation. They also attribute those emissions to the PCF for their water bottles. So part of the water bottle supply chain is going to include that transport. So that's actually going to impact the product carbon footprint of the water bottles they manufacture. Then company A is going to improve their miles per gallon. They're going to add a new vehicle that's very fuel efficient. That's going to reduce their scope 1. It's also going to reduce their product carbon footprint. And then they're going to republish that product carbon footprint. Then we're going to have the water bottle manufacturer use the updated product carbon footprint. It's going to reduce their scope 3 emissions, and it's going to make their PCF for their water bottles more efficient. So this is the workflow of the GHG policy. This allows you through the methodology to recreate a company's corporate structure and their operations. So you start by creating a company profile. You can add entities to that company profile. It could be a joint venture or a subsidiary. You can assign operational assets to that entity that generate emissions, whether that's a facility or a vehicle or equipment. You assign greenhouse gas sources to these assets, and you can attribute the sources to products. That part's optional. You assign data sources to the GHG sources and have the sources verified by a VVB. That's optional. Data sent to Guardian Audio calculates the emissions, and then the GHG inventory, also known as the reporting metrics, can be verified by a verification body, and it's optional that they can publish their product carbon footprint, and then the registry approves issuance requests, tokens are minted, and Guardian generates a report in the form of a trust chain. So what the trust chain is, along this policy workflow, and as data is added, key pieces of information like activity data and emissions factors are encapsulated into verified credentials, and then all of those verified credentials together make up the trust chain, which shows the provenance of those tokens all the way from creating a profile through verification, calculations, and finally minting the tokens. So before we get into the pre-recorded demo, I wanted to take a quick look at the schemas. So here is the Excel version of this schema for company A, the logistics supplier. And these are the main sources that were added. And here we have the calculations that are behind the Guardian policy. So everything you see here in green, that could be auto-calculated by the Guardian, and the other ones are either defaults or user inputs. So you have location and market-based emissions, and you have an option to attribute these emissions to a product or a service. In this case, we're not attributing the electricity to the transportation service. Here's the meter data behind that you would add to the source. But we will be attributing mobile combustion, right? So here's the calculation for mobile combustion. As you can see, we're attributing that to their product or service being road transport services, their product ID, and their allocation percentage. And then if we look at the PCF, this is the main KPI that will be used by supply chain partners, the kilograms of CO2e per declared unit. A declared unit is going to be 1 ton mile of road freight transport. And this is going to be calculated based on all of the emissions that were attributed to that product ID relative to the product amount, how many ton miles they provided in that reporting period. So now let's take a look at the schema for company B, the water bottle manufacturer, and let's take a look at their scope 3 upstream logistics. They're using the Heavy Haulers Corp, their supplier entity ID, how many ton miles they contracted with that company. And right here, we have the supplier specific PCF. But if you look at that emission factor C107, if we go to upstream logistics and we look at this is actually being pulled from the PCF of company A. So that's the PCF that they're going to be referencing. So if we go back to company A, look at their mobile combustion, which is going to be here. And let's say hypothetically we increase the efficiency of these vehicles. We will see that reduce their scope 1 emissions. It will in turn reduce their PCF, and that will in turn reduce the emissions from upstream transportation and distribution, and that will also reduce the PCF. And even downstream from that, suppliers that are purchasing these water bottles, that'll reduce their scope 3 emissions from product purchased from product purchases. So these changes in the supply chain and in emissions, they are going to cascade down the supply chain, making greenhouse gas accounting more dynamic and more accurate. So here we have the Guardian policy, and this is set up for company A right now. And we're going to take a look at their mobile combustion source. So here's the verified credential for that source. As you can see, it's being attributed to the road transport services, allocated 100%. And now we're going to look at the data behind that source. Got the miles per gallon here. So this being the more efficient new vehicle that they added in the demo use case, the verified credential. It's got some key pieces of information, including the miles per gallon and the emissions factors. And then here we have the miles. And the emissions and the ton miles. And now we're going to take a look at the PCF. Oh wait, momentarily. So here we have two PCFs that they published. That was the original one. And they added a fuel efficient vehicle, and the PCF became more efficient. That's view the information behind that PCF, all of the data elements that were outlined by the Pathfinder framework can be found in here. The amount of ton miles characterization factors of the global warming potentials that they used. So now we're going to company B, the water bottle manufacturer, and we're going to enter in data for upstream logistics. So we've got how, and that is going to be attributed to their water bottles as well, allocation of 100%. So all of those all that transportation is being used in the supply chain of their water bottles. And then we're going to add data to that source. But first, we're going to assign the latest PCF, and it will be using that product carbon footprint as an emissions factor. So it'll be multiplied by how many ton miles they contracted by the emissions factor, which is CO2e per ton mile. So we'll assign the PCF. And then the next step is going to be to add data. So here's the source that we defined already. We assigned our PCF, the latest one. And now we'll add data. Now we'll see our emissions. That's our scope 3.4 emissions from upstream logistics. And here's the amount of ton miles that were contracted. And we can take a look at the VC. And we are going to assign that to be verified by the VVB. So we're in dry run in this demo, so that allows multiple users to work through one account. But if this was a real project, the VVB would have a separate login, and it wouldn't be, and that's how it would be operated in a real project. So they verify it. And then they're going to publish a new updated PCF. So now we're creating a PCF for the water bottle manufacturers. So this is the PCF, 0.06 kilograms of CO2e per water bottle. And we'll go ahead and publish that. So the next thing we're going to do, now we're back at company A, and we're going to see what happens if we add a very fuel efficient vehicle to the fleet and we run some data through that very fuel efficient vehicle. So we're going to be adding the vehicle with many miles on it, so that should improve their PCF for their transportation services because they're putting to use a very fuel efficient vehicle over many miles. And I'm going to add, so here's the new emissions calculated in the VC. So emissions are increasing, but the ton miles are increasing way more. So since the PCF is relative to the ton mile, it's actually going to improve the efficiency and it will improve the PCF. So now we'll calculate and publish the new PCF. All the emissions attributed to that product ID there. So here we can see that this the log O2 is very much improved since their last PCF because of that new fuel efficient vehicle and the data we put through that. So we'll go ahead and republish the new one. Here's the VC behind it. Publish that. So they published their new PCF, and now here we are back at organization B, the water bottle manufacturer, and they're going to create some new data utilizing the new, more efficient PCF. So here's the latest one. You can view the VC here. You can see that it's attributed to the water bottle. And we're going to assign the new PCF, which should be RFPCF log 2. And you run some data through that new source with the new PCF behind it. And you can see here with the same amount of ton miles, there's much less emissions using the new, more efficient PCF. So 875,000 ton miles before would result in 61 metric tons of CO2e. Now the same amount is only producing 23. So you're accumulating you're accumulating emissions slower than you would have with the old PCF. So now that there's new data in the policy, company B is going to be recalculating their PCF for their water bottles. So now you can see here, the original one was 0.0611, the new one is 0.0534. So the PCF for the water bottles is actually improved, and that is a result of the improvement that their supplier made all the way up with their scope 1 emissions from mobile combustion. Let's look at the token history for company A. So here we have the trust chain for company A. It's also known as the verifiable presentation. And what we have here is essentially all the key VC files together, and they tell a story of the origin of these tokens and these emissions from the policy creation, the organizational profile, and most importantly, through to the verification of GHG sources and data. Here we have 3 published PCFs and all the key data points that are outlined by the Pathfinder Framework and verified reporting metrics and the key details of that. And finally, through tokens minted. So I also wanted to just go over a few final remarks to wrap this up. So when emissions are tracked and verified in a digital environment and reliable data is shared on a decentralized ledger, it becomes possible to vastly improve the data quality behind scope 3 and product emissions. And you're also better able to reflect dynamic supply chains as they change and as new low carbon solutions are implemented, and as emissions are improved, those improvements can cascade down the supply chain. And this also better helps the identification and incentivize low carbon products and suppliers as they become easier to identify, and the benefits that they offer are better reflected in GHG and product inventories. So I'll stop here and give a chance for anyone to ask any questions. And if not, please feel free to reach out with any questions you might have. And I want to give an opportunity to thank everyone for joining the webinar and for your time today. So thank you.